Hello everyone, in this video we'll be solving problem 73, set matrix zeros. The problem statement is, we are given an m by n integer matrix. If the element is 0, then all of the cells in the corresponding row and column should be updated to 0. And it should be an in-place operation, which means we cannot use an additional memory to store the output. We need to update the input matrix based on the rules given to us. In example number 1, we only have one 0 which is in the center, and this cell is part of the second row and second column, which means all of the elements in the second row and column should be updated to 0, which is reflected in the output or the updated matrix. Similarly, if you look at example number 2, we have two zeros in the first row but in different columns. The first one is in column 0 and the other one is in column 3. Based on this setup, all of the elements in the first row and first column and the last column should be updated to 0. The elements that are not part of those rows and columns are unchanged. The problem statement is very straightforward, but doing the in-place operation makes it a little bit challenging. So let's switch to whiteboard and discuss how we can solve this problem, starting with a brute force approach and following up with an optimized solution. For time being, let's ignore the fact that we need to do an in-place operation. In a brute force approach, I will use an extra memory to store the output. In this approach, we'll do a two-pass iteration through the input array. The first one is to identify the zeros in the input matrix, and the second one will be to update the corresponding row and column to zeros. And if there are no zeros in the corresponding row or column, then we'll take the original value from the input matrix and save it to the output. In this example, as we only have one zero in the second row and second column, the corresponding row and column flag will be set to 0. So when we do the second pass, all of the elements in the second row and second column will automatically be saved as 0 instead of the original value. As we are iterating through the input matrix multiple times, first to identify the zeros and set the corresponding row and column flag to 0, and second pass is to update the output matrix accordingly. While the space complexity is also O of m into n, because we are using this additional memory to store the output. As this requires an additional memory and we are not doing an in-place operation, it does not satisfy the constraints given to us. Now let's discuss an optimized solution to improve our space complexity. When we were iterating through the brute force approach, we were keeping a track on which rows and columns there are zeros. To simplify our previous approach, we can use two separate arrays of size m and n, and each of the corresponding index will suggest us if there are any zeros in the corresponding row or column. And once we have identified which rows and columns have zeros in it, we can simply do a second iteration on the input matrix and update the corresponding rows and columns to zeros. Let's do a quick dry run by running an iteration through this input matrix. Here we have 0 in the first row, third and fourth row. So the corresponding indexes in the rows array will be updated to 0, while row 2, which do not have any zeros in it, will be set to 1. Now we'll repeat the same cycle for the column level iteration. So we have zeros in the first column and the last column. So the corresponding indexes in the column array will be updated to 0, and the column 2 and 3 will be 1, as there are no zeros in the corresponding columns. Both of these arrays can be updated using a single pass, as we will have access to both the rows and the columns pointer. Once we have updated the array with zeros and ones, all we need to do is run another iteration on the input matrix, look up the corresponding value in the rows and the columns array, and if it is a 0, then all of the elements in that row and column should be updated to 0. With this improvement, our time complexity remains the same, that is O of m into n, because we need to iterate through all of the elements in the given matrix at least once so that we can populate these two collections for rows and columns. But the space complexity is improved to O of max of m comma n, as we are using these two collections to determine which rows or columns have zeros in it. Compared to the previous brute force approach, this solution improves our space complexity significantly. Now let's discuss an improvement to the current solution, which will even improve our space complexity further. In the previous approach, we were using an additional collection to record if the corresponding row or column have zeros in it. If we want to improve our space complexity further to constant space, we should be able to use the existing matrix to help us determine which rows and columns have zeros in it. As an exercise, let's break this down into smaller matrix and try to solve it. So we'll take a 3 by 3 matrix in the 4 by 4 input where I'm excluding the first row and column. We can apply the same logic that we discussed earlier in the previous approach and use the first row and column to help us determine which rows and columns have zeros in it. I'll quickly go ahead and update the values in the first row and column based on the values in the 3 by 3 inner matrix. Now that I know which rows and columns have zeros in it in the 3 by 3 matrix, I can run the second iteration on the 3 by 3 matrix and update the corresponding rows and columns value to 0. And as we are not creating any additional memory, this will be an in-place operation. Now you might be wondering what will happen to the original values in the first column and row if we are updating with zeros and ones based on the 3 by 3 matrix. How can we distinguish if there was a zero in the original row and column the first place or it was added as part of solving the 3 by 3 matrix? That's an excellent question, and that's where the beauty of this solution lies. Before we start running an iteration through the 3 by 3 matrix, we'll first iterate through the first row and first column to identify and check if there are any zeros in them. If there are any zeros, we'll save it as a flag in two separate variables. And once we have solved the 3 by 3 matrix, we'll then focus on the first row and column. If the row or column flag is true, it means there was a zero in the original input array. So we'll update all of the elements in the first row or column to zeros. Let's do a quick dry run to understand this approach better. We'll start by checking if there are any zeros in the first row. There is one, so we'll set the corresponding flag to true. Similarly, we'll check the zeros in the first column. As there is one, so I'll set the corresponding flag to true. Now we'll start solving the 3 by 3 matrix by identifying if there are any zeros in any of the rows or columns. The approach is going to be same as before, but instead of updating a separate collection, we'll be updating the values in the first row and column to zeros if we find a zero in any of the rows or columns. After the first pass, I've identified there is a zero in the last column and last row. So the corresponding values in the first row and column have been updated. Now in the second pass, we'll iterate to the 3 by 3 matrix again and update the corresponding rows and columns to 0 wherever we have a 0 in the first column or row. With this update, we have solved the 3 by 3 matrix. Now we need to focus on the first row and column. As we have already identified that there is a 0 in the first row and first column, so we can simply run a loop through those elements and update the values to 0. And once we have updated all of the values in the first row and column, our output is ready to be returned. With this solution, our time complexity is O of m by n, unchanged when compared to the previous approach we discussed. And the space complexity is improved to O of 1 as we are only using these two variables to record if the first row and column have any zeros in it. I hope you are able to understand this explanation. Let me show you how we can implement this approach using C#. In this C# implementation, I've broken down my solution into smaller pieces, starting with the for loop to identify if there are any zeros in the first row, following up with checking if there are any zeros in the first column. After that, I'm running a for loop to iterate through all of the elements, excluding the first row and first column, that is the smaller matrix. This pass will help me determine which rows and columns have zeros in it, and I'm updating the corresponding values in the first row and column with zeros. After updating the first row and column values to 0 based on the rows having any zeros in it, now we need to update the remaining elements in the corresponding row and columns to 0. So in the next for loop, I'm checking if there is a 0 in the first column and first row and accordingly updating the values in that row and column. Once this loop is complete, all of the elements in the sub-matrix will be updated based on the rules given to us in the problem statement. After that, I'm using the flags first row 0 and first column 0 to check if the first row and column should be updated to 0. If the flag is true, then I'm running a loop through the first row and column and setting all of the values to 0. As we are doing an in-place operation, we don't need to return anything. as all of the values are being updated directly into the input matrix. This code, when submitted on LeetCode, beats 74% of the submissions in terms of runtime and nearly 50% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.